In our lesson today, we're going to look at another application of multiplication, which is involving exponents. And then later on in the lesson, we're also going to have a review of all of the operations that we have worked on so far this year. So let's take a look at our exponents. Exponents, if you remember, allow us to repeatedly multiply by the same number. For example, okay, this is read as 5 to the third power, all right? And what this means to do is that I'm going to take the number 5 and I'm going to multiply it by itself 3 times. 5 to the third means to do 5 times 5 times 5. Okay? The 5 has a name, okay, and this is called the base. And the base is the number or expression that is used as a factor in repeated multiplication. Okay, so this was the value that was repeatedly getting multiplied. The 3 is called the exponent. Okay, and the exponent tells you how many times to use the base as a factor, how many times you're going to multiply it by itself. So this is the exponent, all right, the exponential notation, 5 to the third power, and this is the expanded form when you write out what it means to do, 5 times 5 times 5. Now we're going to evaluate and see how much that is. 5 times 5 is 25, and 25 times 5 is 125. So 5 to the third power is equal to 125. In the last example, our base was a positive number. If your base is a negative number, then you need to think about whether the answer will be a positive number or a negative number. Example number 1, we're going to write each exponent as a multiplication problem, and then we're going to evaluate it. So notice my base here is -2, and it's going to be -2 in all of these examples. And again, the exponent tells you how many times you're going to multiply -2 by itself. So in this first example, it's very straightforward. I just need one copy of -2, and there it is, okay? Any number that's raised to the first power is going to give you that number back. -2 to the first is the same as -2. -2 to the second power, this also might be called -2 squared. That means I'm going to do -2 times -2. And when I do this multiplication problem, remember that a negative times a negative is a positive, and 2 times 2 is 4, so -2 times -2 is +4. -2 to the third power, when you raise something to the third power, they might also call it cubed. -2 cubed means to do -2 times -2 times -2. Okay, and now if we do the multiplication, -2 times -2 we just said was 4. So we have to do 4 times -2. A positive times a negative is a negative, and 4 times 2 is 8. With letter D, -2 to the fourth power, that means to do -2 times -2 times -2 times -2. And now again, we'll go from left to right. -2 times -2 was 4. Bring down the rest of the problem. 4 times -2 we just said was -8. So we have -8 times -2. Again, a negative times a negative is a positive, and 8 times 2 will give us 16. Finally, in letter E, -2 to the fifth power. We're going to have 5 copies of -2 that we're going to multiply by itself. There's what -2 to the fifth power looks like in expanded form. And so now when we evaluate, again, -2 times -2 is 4. Bring down the rest of the problem. 4 times -2 was -8. Bring down the rest of the problem. -8 times -2 we just said was 16. And so now we have 16 times -2. A positive times a negative is a negative. And 16 times 2 is 32. So hopefully you're seeing a pattern, all right? In example number 2, do you see the pattern? We're going to fill in the blanks below. If a negative number is raised to an even power, okay, well that would be this example right here in letter B and this example right here in letter D. Every time that we raised the negative number to an even power, our answer ended up being a positive. So you will get a positive result if you raise a negative number to an even power. But if you raised your negative number to an odd power, like in example A, example C, and example E, notice this time that that's going to give you a negative result. A negative number raised to an odd power will give you a negative result. Notice that each time you raise a negative number to an exponent, you need to use parentheses. In all of these examples, when I was raising the number -2 to an exponent, I had to put the -2 inside of parentheses. Okay, if you forget the parentheses, this can lead to an incorrect answer. In example 3, notice how these two look similar, but there's one slight difference. Okay, on the right, -5 is in parentheses, and on the left, -5 is not in parentheses. These two are not equal to each other. If we take a look at the left expression, -5 and then to the second power, all right, what this means to do is to take that value and 0 minus 5 to the second power. -5 without the parentheses to the second power means to do 0 minus 5 squared. Okay? And this actually is going to relate to something we're going to talk about in just a moment, but with order of operations, you need to do the exponent first. So this means to do 0 minus 5 squared is 25. And 0 minus 25 is the same as 0 plus -25, which gives us an answer of -25. However, on the right-hand side, where -5 is in parentheses and we're raising it to the second power, that means to do -5 times -5. Okay, and if you use your rules of multiplication, a negative times a negative is a positive. 5 times 5 is 25. Okay, so the value on the left gave us -25. The value on the right gave us +25. They are not the same answer. Okay, so the moral here is that if you're going to raise a negative number to an exponent, you have to put it in parentheses. The next part of our lesson is going to focus on the order of operations. In mathematics, there's a proper order that needs to be followed when there's multiple operations within an expression. If you don't follow the order of operations, then you won't be able to come up with the correct answer when you try to evaluate your expression. In example number 1, Bobby said that the answer to the expression below is -3. Is Bobby correct or incorrect? Okay, the expression says 6 divided by 3 minus 4 times 2 plus 1, and then he thinks the answer is -3. We have to follow the order of operations in order to see if he's correct. Okay, so let's review the order of operations. The very first thing that you're going to have to do whenever you're looking at an expression is evaluate any expressions within grouping symbols. Grouping symbols. Okay, any operations within grouping symbols need to be evaluated first. And the most famous grouping symbols would be parentheses, which we know looks like this. Okay, but other grouping symbols could be brackets, which are like square parentheses if you draw them like this. Okay, or braces, which are those kind of squiggly looking things like this that are a lot of fun to draw. Those are called braces. And another form of grouping symbols that we've actually talked about before this year would be absolute value bars. Like that, okay? Any operations that are inside of these grouping symbols need to be evaluated first. After you evaluate expressions within grouping symbols, then you can evaluate any exponents that you see in the expression. Following your exponents, next is going to be multiplication or division working from left to right. Working from left to right. Okay, multiplication and division are on the same level, so whichever one happens first in the expression, that's the one that you're going to do first. And then the last layer is addition and subtraction, again working from left to right. If the subtraction shows up first in the expression, you'll do the subtraction first, and if the addition shows up first, then you'll do the addition first. So, keeping this in mind, we're going to see now if Bobby was correct when he said that the answer was -3. So here's the expression that Bobby had above, and we're going to follow the order of operations and see if we get the same answer of -3. So evaluate any expressions within grouping symbols first. Well, in this problem, I don't see any grouping symbols at all, so I'm going to move on to the next level, which would be exponents. And again, looking at this, I don't see any exponents, so we're moving down to the third layer, multiplication and division working from left to right. So going from left to right, I see a division problem first, so that's going to be the first thing that we need to evaluate. 6 divided by 3 is 2. Now bring the rest of the problem down. Minus 4 times 2 plus 1. Still on level 3, again, any other multiplications or divisions that we see have to be done first. I see subtraction. There's another multiplication right there. So I'm going to bring down my 2 minus, and now I'm going to do 4 times 2, which is 8, plus 1. Okay, and that takes care of all the multiplications and divisions. We're only left with subtraction and addition, so we're on the last part of our order of operations now. And again, we have to go from left to right. So 2 minus 8 is the first part of this problem. 2 minus 8, remember, is the same as 2 plus negative 8, and 2 plus negative 8 is equal to negative 6. So this gives us negative 6 plus 1. And so the last thing that we have to do now, negative 6 plus 1, this is going to give us an answer of negative 5. Bobby said that the answer was negative 3. So we can safely say now that Bobby was incorrect. Bobby was incorrect. Okay? Bobby's mistake was that he just worked straight from left to right, ignoring the order of operations. Okay, so make sure that you follow this proper order so that you can come up with the correct answer anytime you evaluate an expression. In example 2, we're going to evaluate each expression, and it's important to show all steps in your calculation. So looking at letter A, okay, here's our expression, and I'm looking for grouping symbols first, and I actually see an operation in the grouping symbols. Addition is inside of the parentheses. So this is the first thing that I'm going to do in the problem, negative 2 plus 4. Okay, so I'm going to bring everything else down, negative 8 rather, plus negative 3, and then when I do negative 2 plus 4, that gives me an answer of 2. And then notice there's an exponent, so I have to put that above there as well. So our expression now says negative 8 plus negative 3 times 2 to the second power. Okay, now this parentheses here, these are grouping symbols, but there's no operation in the grouping symbols. So we're going to move on to the next step, which is exponents. And this right here says to do 2 to the second power. So again, I'm going to bring everything else down, negative 8 plus negative 3 times, if you do 2 to the second power, 2 times 2, that gives you 4. Okay, looking at this now, I see addition and I see multiplication. I'm going to do the multiplication. So negative 8 plus negative 3 times 4. A negative times a positive is a negative, so that's going to give us negative 12. And the last thing we're going to do is negative 8 plus negative 12, which is negative 20. In example B, what we're going to do first, again, I'm looking for operations in grouping symbols. These parentheses, all right, do not have an operation, so I'm ignoring that. But this grouping symbol, the absolute value bars, does have an operation, so we're going to do that first. So we're going to have 3 squared plus negative 2 to the third power plus the absolute value of negative 6 plus 2. Negative 6 plus 2 is negative 4. Okay, now we're actually going to take that absolute value. So again, we're going to have 3 squared plus negative 2 to the third plus the absolute value of negative 4 is 4. Next, we're going to do our exponents. 3 squared, 3 times 3 is 9, plus negative 2 to the third power. If you remember from earlier in the lesson, negative 2 times negative 2 times negative 2, that was negative 8, plus 4. And now just its addition, go from left to right. 9 plus negative 8 is 1. And finally, 1 plus 4 is 5. Another form of grouping symbols would be the fraction bar. If you have an expression in the numerator and or the denominator of a fraction, you need to evaluate those first before you can do the division represented by the fraction bar. Okay, so I have expressions in both the numerator and the denominator. So what I'm going to do, I'm going to start with the numerator. All right, I have division but parentheses here, so that's going to be 35 rather, divided by 5. In the denominator, I'm going to multiply first, so this is going to be 20 minus 14 plus 1. All right, in the numerator, 35 divided by 5 is 7. 20 minus 14 is 6. And then 6 plus 1 is 7. So this is 7 divided by 7, which is going to give us a final answer of 1.